Welcome to Manufacturing Tech Australia with Shane Williams and Paul Mason.
Brian, welcome to Manufacturing Tech Australia. Thanks for coming on the show. So Brian from Conflux, I actually just did a little tour of your facility a couple of weeks back. Amazing 3D printed stuff down at Wampons on the Deakin Uni site there. Anyway, I'll let you tell the story.
That's
tell us a bit about what you guys do.
Our company got founded as a gentleman by the name of Michael Fuller had the idea that, for high performance applications, you could reduce the size and weight of the components while still maintaining the same performance if you were to additively manufacture the heat exchanger. With additive manufacturing, we've got full control over the geometry of the parts, so we can get the same amount of heat transfer potential in a smaller package because we've got such fine control over the details, and we can get it, very densely, packed together. That's what we've been doing. The additive manufacturing gives us the secret sauce to allow us to provide the high performance heat exchangers for a variety of applications. And we're also not limited by geometry of traditional, tube and fin, plate and frame exchangers. So if there's a special application where we need to be able to conform to a curve, reduce the size, things of that nature, it's also a very good solution for that.
Yeah, I mean, there used to be like cast a pile of parts, right, stick them together, and a bunch of different processes, maybe 10 different parts will go together. Now,
with something like this, you don't have the leak potential that you get with like a plate and frame type of exchanger because you don't have to gasket the heat transfer surfaces. It's all monolithic. Yeah. So that's another advantage that we have being able to 3D print parts such as this, is that, there's no gaps such as that to form leaks. So there's less potential maintenance involved with that. Basically, once you manufacture the part, you can install it, and it's good to go. It doesn't have to be continually maintained and whatnot, the way a plate and frame exchange, for example, might have to be.
Yeah, what about, obviously, there's lots of advantages in being able to customize and things like that. But what about like validating a part to go into a vehicle or whatever application it is? How do you prove that that's ready?
We can do our own pressure testing on site. So once we get a part off, we can verify that the FEA models that we've done are accurate. So we do our own computational fluid dynamics and design work in-house. So we can do simulation on, measure the potential for bursting or, deformation under pressure. And then once we get the part printed, we can validate what the model told us. Once it comes off the printer, we can pressure test it to make sure that, the analysis that we did before was accurate and that it's going to hold without deformation.
Yeah, right. And I guess if you have any faulty bits, melt it back down and go back to powder and start again.
Make the necessary changes, and then we can, make an iteration of the part to get to where we need to be if it turns out that there was something that we didn't see in the first round through in simulation. Yeah.
So I guess being highly customized, lightweight, compact, those kind of things, like lends itself to aerospace, to high performance vehicles. So what kind of applications are we talking?
Various applications. Like for example, this is kind of an example of an aqueduct, which you can see in the drone over here. It's a very low drag weight of getting air through an inlet of some kind. In this case, we've got the ability to cool off air or oil with this design here with very low drag configuration. This here is the exchanger that went into the cabin air climate control system of an aircraft. And then other various applications, we've been getting a lot of interest lately in recuperators for gas turbine engines, which increases the efficiency by recovering some of the waste heat that's normally just thrown away in the exhaust. But we have a special high-temp material to take advantage of that we can also print in.
I guess what's for the future now? What other type of applications are you looking at? Other materials, other technologies?
Getting more into being able to provide certifications for space applications in particular, and broadening the aerospace exposure that we have and a variety of bonus we can offer for that.
Excellent. I guess supporting the space industry here is a big part of it.
Yeah, it's especially now with alternative fuels like hybrid electric vehicles. There's a need to keep the battery packs within operating temperature so they don't overheat. So we came up with a concept we refer to as a cold plate. So you've got coolant that goes in through here while this is packed inside of a battery pack. So this is sandwiched with it. So this provides thermal management in the interior of the battery pack to ensure that the cells in the back don't overheat, to maintain a consistent temperature across, so they wear in a predictable way.
Yeah.
We've got a design for that. This has applications both for hydrogen fuel cell, thermal management, battery packs, and instrumentation as well. With gauge clusters becoming tighter and having more, computerized components, there's a need for avionics to keep them cool as well. And this has the application there as well. When contact to the panel, it can, shed the heat.
I see. So super high tech heatsink, basically.
One of the nice things about being able to completely control the geometry of something like this is that we can vary the fin gap on the interior to make sure that the fluid spreads out evenly across the plate. Where there's a gap where there might be high pressure on one side, we can spread the fins out to encourage the coolant to go out to the edges more, to keep it consistent across.
Okay, fascinating.
Yeah, that's something that you can really only do with 3D printing.
Yeah, perfect. Excellent. Well, it sounds like sky's the limit. We're certainly getting a lot of noise in the background, yeah? Brian, thanks heaps for coming on the show. Appreciate having a chat with us.
Thanks for tuning in to Manufacturing Tech Australia with Shane and Paul, recorded on the traditional lands of the Bunurong and Wurundjeri people. For more information, jump on the manufacturingtech.au website. Remember to hit the follow button to join us again next time as we continue to explore the intersection of manufacturing and technology.